Hello everyone, welcome to my YouTube channel. My name is Bappy Ahmed and I'm your host. So in this video actually I'm going to discuss about one amazing model just recently released. I think you have heard of YOLO, right guys? So you have heard of YOLO V5, YOLO V6, YOLO V7. So finally YOLO V8 also came, okay? So I'm just talking about YOLO V8. So it is from Ultra Analytics. I think you used YOLO V5 from Ultra Analytics. Okay. Even I have, you can say, lots of tutorial in my YouTube channel. If you just check my playlist, you will get, you can say, YOLO V5 related project also. Okay. So I already showed you like how to install YOLO V5, okay, how to use YOLO V5 on your custom dataset. Even I also created YOLO V6 and YOLO V7 as well, okay. So now actually they have recently published this YOLO V8 and it is like one of the amazing model. Why I liked this model so much, because let me tell you, using just one model you can perform three kinds of tasks, okay. Like I think as of now you have done object detection, okay, with YOLO V5 or YOLO V6, but this is the first time they have introduced three kinds of tasks with this YOLO V8. So using YOLO V8 actually you can do object detection, okay, see this detection. So these are the detection model. You can also perform image segmentation, okay. So this is the segmentation model, and the new things they have proposed, which is nothing but image classification, okay. So before that, for the image classification, what we used to do, we used to like use Inception, ResNet, okay, VGG16, these are the architecture. But recently they have also introduced like classification with YOLO V8, okay. So this is one of the amazing thing I liked so much. And see, these are the model guys, okay, and it is still under development. So they needs to, like, you can say, change a lots of thing here. So you might face some issue, okay, but don't worry, as time passes, okay, so they will be like fixing all the thing. And if you have any issue, okay, with the setup or with your you can say project or anything, so just come to this issue section, okay. And here you actually you can like create your issue. You can like tell them this is the like issue you are having. So and see, this is like very active like repository, just 1 hour ago like they have committed, okay. So they will look into your issue, okay, and they will fix that as soon as possible, okay. So yes guys, this is the official GitHub like from Ultra Analytics, okay. So now actually one thing I also liked of this YOLO V8, like you don't have to like clone this repository. And I think you saw like YOLO V5, YOLO V6, we used to clone the repository, we used to set up like requirements, okay, then we used to configure the model file, okay. So there was like lots of manual like task, okay. But here actually you don't have to do, these are the things. So you just only need to install this Ultra Analytics. And there are two way to use YOLO V8. One is like by using your CLI, that means command line prompt, okay. And another is like your Python script, okay. So you can run both of them, but I will show you like how to use CLI and how to use like Python script, both of the way I will show you, okay. But what I feel like, I like this command line utility, because like it's like easy to like execute all the command, right, instead of writing this Python code. So now in this video, let's install this YOLO V8, okay. And I'll show you like how to like you can say train this YOLO V8 on your custom dataset as well, okay. Then I will also show you like how you can use their pre-trained weights also, okay. So this is the, actually you can say benchmark. Here if you see, this is the YOLO V7, YOLO V6 and YOLO V5, and this is the YOLO V8 result guys, okay. And I was watching some of the, you can say, videos. I was watching some of the benchmark. So what I saw, like this YOLO V8 is like more faster than your YOLO V5, YOLO V6 and YOLO V7, okay. If you are training YOLO V8, you will observe, okay, it is like more faster, and it is like more powerful model, okay, and it's like more lightweight model, okay. So recently they have proposed around 5 models, but in future I think they will be releasing more, okay. So now there is a documentation, they have also released of this YOLO V8. Here if you see, these are the documentation. So you, if you have time, you can go with this documentation if you want to learn more about, okay. But let's start with our agenda. Okay, so let's install this YOLOv8. Okay, first of all, so here I'll be using Google Colab because I'm expecting like okay, everyone won't be having GPU in their system. Okay, so that's why I will be showing inside my Google Colab. So that actually at least you can use free GPU there. Okay, but the same way you can also run in your local machine. Okay, so let's do it. So first of all, I will open my Google Drive. So you can open up your Google Drive. Okay, so here what you need to do, you just need to just create one collab, you can say notebook. Okay, so I'll create one collab notebook here. Okay, so I will give this notebook name as yellow v8. Okay, so first of all, let's install. Before installation, I need to connect with my GPU, and let's also connect our notebook. Just click on connect. Okay, it will be connecting. So guys, on my notebook has connected. Now what I need to do, if you want to test like whether you got any GPU or not, just write this command nvidia -smi and execute this command. So guys, as you can see, I got Tesla T4 GPU. Okay, so to install this YOLOv8, just come here. So there is installation guideline, as you can see here. Okay, so they're telling like you need like Python version equal to, you can say, more than 3.7. Okay, and you can also use latest Python version. It will also work. So and these are the requirement. Okay, here if you see, if you just go click on this, so you can see all the requirements. Okay, to install this YOLOv8. So I don't have to separately clone this repository and install this requirement.txt. So instead of what I will do, I will copy this command pip install ultra analytics. Okay, so let's copy this command and I will come to my notebook and let's execute this command. Okay, it's like very like easy to install and very easy to use. Like it will like save your time a lot, guys, just trust me. I was just like exploring this one and I was totally fascinated like how like you can say easy way like they have developed this thing. Okay, it's just like a Python package. Just install the package and try to execute some of the command, your job would be done. Okay, you don't have to do any configuration, anything. Only you just need to do prepare your dataset and just give it here. Okay, that's it. So installation is done. So now if you want to test like whether it's working fine or not, so let's execute this command. So this command is nothing but uh, it will download one model. So let me explain like what it will do. So basically, see, this is the command. So you just need to like call YOLO, okay, and predict. Okay, so uh, like it has like some of the modes. Okay, so let me tell you about the modes. So there is one notebook I prepared here. So it has like three modes. One is like train modes, validation mode, okay, and prediction mode. Okay, task, it can perform three kinds of tasks, as I told you: detection, segmentation, and classification. Okay, data format, it can support. Format can be differ for the task type, definitely, because as per your task you need to give your data with respect to that format, and supports data like data.yaml. Okay, so basically I think you used YOLOv5. So they're actually the format you used to use. Okay, data format you used to use in YOLOv5, the same data format you can use here. Okay, it will work. And here if you see, as I told you, it has three kinds of task: detect, segment, and classification. And it has three more: train, validation, and predict. Okay, so here basically what I want to do, I have installed YOLOv8 in my environment. Now actually this is one image. Okay, if I show you, if I copy this image, okay, so this is one bus image. Okay, this image is present inside ultra analytics github. Okay, so here this is one image. So I just want to test my model whether it is able to detect or not. Okay, these are the objects, okay, in this present in this image. Okay, so that's why I'm just telling predict. Okay, instead of training and validation, I'm calling predict because I want to inference my model. Okay, then which model I want to use, here I'm giving model equal to YOLOv5 8n.pt. Okay, now why I'm getting this name, as I told you, just come here. It has three kinds of task: detection, segmentation, and classification. With respect to your task, choose the model. See, here I'm using that model, YOLOv8 n model. Okay, if I show you this model I'm using. Okay, so just name the model and just give .pt. Okay, and source equal to your image location. Okay, so here I'm using URL, so that's why I'm passing the URL. Now if I execute this cell, so first of all it will download the image and it will download the model, okay, from the internet. Then it will do the prediction. Okay, so one issue actually I observed. When I was referring their tutorials, okay, like YOLOv8 official tutorials at the time, like whenever they were running this command, okay, so it was creating a folder called runs. Inside runs, it was saving all the detection images. But here when I was running, okay, it is not saving. Instead of what it is giving like, see, your all the classes name, like this image contains 4 person. If I open this image, 1 2 3 4, okay, see, it is also detecting this half of the person. And it's telling one bus. So yeah, there is one bus. And it is also telling one stop sign. Okay, and yeah, so these are the like object it is able to detect. Okay, and I can see, yeah, these are the objects presented in this image. Okay, so instead of like creating this runs folder here, saving the image, okay, as a detection, what it is giving like that. Okay, I don't know like whether they have changed in their repository or not, because see, it is still under development. Okay, so if you see, they have just committed 2 hours ago. So I don't know like whether they are changing anything or not, but I think it will work later on. Just try it. Okay, let me know in the comment section whether it's working for you or not. So what I will do, I will raise one issue, okay, in their repository, like I'm not getting this runs folder, I'm not getting the detection image here. Okay, instead of that I'm getting as a, you can say, comment output. Okay, so what would be the solution? Okay, if I get any solutions, then I will create another video on that. Okay, but as of now, I'm just showing you the like process how you can use this one. Okay, you have to use the similar way to use this YOLOv8. Okay, if you have your custom data or if you want to use any pre-trained weights. Okay, so that's it, guys. So now I think you got it, like how I have installed YOLO Ultra Analytics and how to run this YOLOv8 like model. Okay, by using command. So in this video, actually, I'll be only considering about the object detection. Yeah, like in our next video, actually, I'll try to create like how to do image segmentation as well. Okay. So it was like detection, okay, detection task. But if you want to let's say perform like I mean image segmentation, so what you can do, okay. So let's also let me also show you. So what I will do, I will open my this notebook. Here actually I have prepared all the command and everything. Okay, so let me show you. So I will uh, let's stop this session, okay, because I'm using free collab, and I will connect this notebook. So I'll share all this notebook with you, okay, in the description, so you can access all the notebook. Okay, so let's install it. Okay, now if you want to check your current working directory, so I'm inside my content. So as I told you, so let me create one folder here called data or image. Okay, because here I have located as images. Okay, inside images I will upload one image. If I go to my download, so there one cat images I downloaded. Okay, so I will just upload this inside the images. Okay, let's see, just for testing purpose. Okay, I'm keeping my own image. Okay, okay, so if I open this image now, so there one.jpg is there. Okay, and it is nothing but it's a cat image. Now if you want to perform detection task, okay, so what you need to do, as I told you, it has 3 mode. It can perform 3 tasks: detection, segmentation, classification, and it has 3 mode: train, validation, and predict. Okay, suppose here I just want to do the prediction, okay, using their pre-trained weights, and task I want to perform, which is nothing but detection. So here you can mention task is equal to detect, mode is equal to predict, model is equal to the model you want to use. Come here, like choose the model, okay, and give it here. So I'm using this model, this 8N PT model. Okay, and your image location. Okay, so here I have image inside this location. Okay, now if I execute this one, and this is the command base. Okay, so here I'm running, this is the command base, or you can talk about CLI based, and I will also show you like how to execute using Python script. Okay, both way is possible here. So guys, see how it has detected successfully, so it is telling it's a cat. Okay, the class is 1. Okay, so I already told you it's not creating the folder here, runs folder, inside that it is not saving the image, instead of it's giving the output like that. Okay, I will contact and I will try to fix this one. Okay, as of now just try to consider it has detected cat. Okay, I'm getting the cat because here I kept cat image. Okay, cat image guys. Okay, so now similar wise you can also perform segmentation. For this what you need to do, just mention task is equal to segment, mode is equal to predict. Okay, and here you just need to pass your segmentation related model. So come here, expand this segmentation. So this is your segmentation related model. Suppose if you want to use this model, just open in a new tab. Okay, it will start download. So I won't be downloading, I will just copy the link. Okay, copy the link address, and if I paste here, and here if you see the last one, okay, so this is your model name. Actually just copy the name, come here, and just try to paste here. Okay, so this is the model name. So that's actually you can get the model name, and I'm giving the source image. Okay, now if I execute this one again, so it's downloading the model, and this is my detection model. Okay, previously it has downloaded. Okay, so again it's telling it's a cat. Okay, and you can also get the segmentation like you can say points. Okay, so let me show you using Python script. Now the same command actually you can execute as Python script. So for that what you need to do, you need to import YOLO from Alta Analytics. Alta Analytics we have already installed. So I'm just doing from Alta Analytics import YOLO, and here I'm loading segmentation model. So just write model equal to YOLO, and inside that just mention the model name. Okay, that's it. Now model dot predict. Okay, if you want to do train, you need to give train. If you want to do validation, you need to go do validation. If you want to predict, just write predict here. Okay, then mention your source image path. That's it. Now if I execute, so this is the Python script based. Okay, you can run this YOLOv8 in both way, command line and your script. Okay, now see guys, this is your segmentation detection points. Got it? So yes guys, I think you got it. Now if you want to also perform classification, it is also possible. So here instead of detect and segmentation, inside the task you need to mention classify, predict. Okay, give the classification model, come here, expand classification, get the model, copy the link address, paste it here. This is the model name, copy. Okay, and paste it here. Okay, now mention your source image file path and let's execute. Okay, I'm showing you all the possible like way. Okay, so that actually you can get the idea like what are the things they have proposed. Okay, but I will separately create a new video like how to do segmentation on your custom data, how to do classification on your custom data. Okay, in this video I will only show you like object detection part. That's it. So yes guys, I think now you should be familiar with this YOLOv8. Okay, a little bit like what are the things like they have proposed. So now what I will do, we have tested with our pretend weights. Okay, now let's prepare our data set. Okay, now we'll be training our own custom data. Okay, so for this what I need to do, first of all I will show you, I have already prepared the image. Okay, I have already annotated the image, so it is the same format as your YOLOv8 sorry, and it is the same format as your YOLOv5. Okay, so in YOLOv5 we used to create image folder, inside that we used to keep image, then we used to create rebels folder, we used to we used to keep our like this label.txt. Okay, so this is the txt file, inside that you have all the coordinate point with respect to that layer label id. Okay, so the same thing, if you don't know like how to annotate the data, I will also show you, don't worry. Okay, so it is already prepared this data, so you just need to create 3 files, test, train and validation. Inside train you need to create again 2 folder, image labels. Inside image you need to keep all your images, inside labels you need to keep all your annotation. Okay, with respect to that images. Similar wise for testing, similar wise for validation, and one additional file you need to create called data.yaml. Okay, so now let me show you what is this data.yaml. So if I open it using notepad++, this is the same thing we used to write in our YOLOv8. Okay, so here you just need to mention your data path. Okay, like where you have kept your data, number of classes you need to mention. So in this dataset I have 5 classes. So the dataset actually I'll be using, which is nothing but, so the dataset actually I'll be using here, which is nothing but industry safety gears dataset. Okay, so let me show you the dataset once, like how it will look like. So this is nothing but industry safety gears dataset. So basically in an industry, whenever any, like you can say, employee works or any worker works, okay, so they need some safety gears to wear, okay, to prevent lots of accident, okay, happens in the industry. So this is the detection we need to perform here. So basically I will be detecting helmet, goggles, jacket, okay, hand gloves, footwear. Okay, so these are the you can say equipment I will be detecting. Okay, so you can use any dataset, but I will be using this dataset because I already prepared this dataset for me. Okay, and these are my 5 labels: helmet, goggles, jacket, gloves, and footwear. Okay, you need to write here. So now let me show you like how you can annotate these are the data, like which tool you can use. Okay, so for this what I will do, I will keep some of the image for just experiment purpose. So I'll copy, because I just want to show you like how to annotate the data. Okay, I'm not going to show you the entire annotation, although I'll provide the data with you. Okay, so let me create one folder here. Inside download, let's create one folder called test. Inside that I will keep I'll create another folder called data. Okay, let's keep this data here. So let's say you have like collected this as the data. Now you need to annotate. Okay, now how you can annotate? Now for this you need one tool called label img. Just come to Google, okay, and search about label img. Okay, so here just open the first link. So here this is the label img official GitHub. So here you have the installation guidelines. So for this you need to create one conda environment. So I'll open my terminal here. Okay, so now here just copy the command. So you can install using pip. So I'll copy this command, and also they have mentioned for Ubuntu and Mac OS. Okay, you can use whatever system you're using, just try to follow these are the command. So here I'm using Windows, so I'll be executing this command. Okay, so here I'll paste, and instead of pip3 I'll just run pip. Okay, just remove the 3, okay, from the pip. Now let's execute. So here you can create one virtual environment, but I haven't created any virtual environment here. Okay, you can create. Okay, I think it's done. Now let's clear. Okay, so now what I will do. So guys, installation is successfully done. Now here you just need to execute one command called level. Make sure I should be capital. Okay, img. Now if I execute, it will open this level img UI. Okay, so now here what you need to do, you need to open your data directory. So I will just click on open directory. Okay, so here I kept my data inside download test folder. This is my data folder. Okay, so these 3 to 4 images I kept there. Okay, now here you just need to change also your change save directory. So I will select the same folder. Okay, this data, make sure you have select the same folder where you have kept your data, because there actually it will save the annotation file. Okay, so once everything is done, now this is my image. Okay, so now here you just need to start annotating your image. Okay, but make sure you have changed this Pascal VOC to YOLO. Okay, anything you have here, create ML or Pascal VOC, just change to YOLO, because here I'll be using YOLO. So that's why your dataset should be also in YOLO format. Now here what you need to do, you need to click on create rectangle box and try to annotate, okay, which portion you want to annotate. So let's annotate. So what is my label name for globes? So yeah, so I'll copy the name and here I'll paste it. Okay, gloves. Now I'll click on OK. Okay, similar wise, uh, let's again take one rectangle, and this is the helmet. So you can write helmet here. Okay, I'm just showing you like how to annotate helmet. And yeah, that's it. I think in this image I can only see, you can also mention the goggles, but it's not visible. Okay, you can ignore. Now once it is done, click on save. Okay, now if I open this folder, so here you will see one annotation file. Okay, this with respect to this image one. Okay, this is the one.jpg, this is one.txt. Now if I open this one.txt, you will see like all the bounding box coordinates it has present here. So let me show you. Okay, see, these are the coordinate points it had saved. So the first annotation I did, which is for gloves. Okay, so gloves has been labeled as 1, sorry, 0, and this is the gloves coordinate. Okay, and this is the helmet coordinates, so it has denoted as 1. Okay, so that's how actually you can get all the txt file. So once it is done, now click on next image, and again click on rectangle, again annotate. So it is for gloves. I will select gloves and click on OK, and again do it for this one. Okay, now I will click on save. Now if I again open this one, it will create another 2.txt with respect to this image, and if you open this file also, you will see the same. Okay, so that's actually you can do for all the images present inside your folder. Okay, so I already annotated these are the images, so I won't be annotating. Okay, so let me show you. So once you have done the annotation, you need to create this folder structure like that. Trend test validation. Okay, and data.yaml file you need to create. How to create data.yaml file? You can open up your let me show you. Let me go to this download. You can open up your VS Code or anything, PyCharm, whatever you are using. Okay, so here you will get create file option. So you just click here and just write data.yaml. Okay, so it will create a data.yaml. Now there actually you need to write all the code. Okay, all these are the thing. Okay, so yes guys, this is all about like how to create the YAML file. Now let me show you. That's how you need to prepare the folder. So inside train, just keep your training images. Okay, so I kept around 120 images. With respect to that images, I kept all the label file here. If you see the name here, so this is 31, 32, 33, 34. Similar wise, I kept all this 31, 32, 33, 34. Okay, make sure this name should be same. Okay, this txt file should be this image. Okay, don't take any other images. Okay, here, otherwise it will throw error. So with respect to that, for testing you need to keep the same thing. Okay, so for validation, again you need to keep the same thing. Okay, I hope it should be clear. Now once everything is done, create this data.yaml folder. Inside that, just mention your these are the thing, your data location. I've kept data/train image, although I will change this location. Okay, whenever I will be uploading this data in my collab. Okay, then mention number of classes and your names. Okay, all the label names. That's it. So yes guys, I think you got it, how to annotate the data and how to prepare your data set. Okay, so I think now it is done. So what I did, here if I show you, I created one folder called data. Inside that I kept all of my file. Okay, now this file you need to upload in your Google Drive. Okay, so guys, we have prepared our data, so I will share this data with you so you can use my data set. So now what you need to do, you need to upload this data in your Google Drive. So I will open my Google Drive. Okay, so here I will be uploading. So just do one thing, drag and drop. So just drag and drop here. So it will take some time. Okay, once it is done, I will come back. So guys, I have successfully uploaded my data here. So now what I will do, I already prepared one this training notebook. Okay, so there actually I mentioned all the code. So I'll quickly upload this notebook here. Okay, and I'll show you. So guys, this is the notebook. I'll just drag and drop here. I will share everything with you. Okay, we'll get this. So the notebook name would be YOLOv8 object detection and custom dataset. Okay, now I'll double click to open this one, and I think our previous one is running. Okay, so let me stop this one also because I'm using free collab. Terminate, close. Okay, now you can remove this thing, I think. It's not required. Okay, so this is the notebook, guys. So make sure you have selected runtime as GPU, save it and connect the notebook. So guys, after connecting your notebook, just execute this command and you will be able to test your GPU here. Okay, so now here, first of all, let's install YOLOv8. So let's execute this command. So to install, you need to run Ultra Analytics. Okay, and here if you see, I'm installing a specific version because as they're telling, it is still under heavy development. Okay, so it may change something, okay, in the repository. So that's why they're suggesting to use these are the version, okay, to install. So that's why I was going through their documentation and I got to know. Okay, now that's why you can also install Ultra Analytics like the previous way we did, okay, in our notebook. You can do it here. Okay, but let's install this specific version. Okay, and these are some utility package I'm importing. Okay, now once everything is done, let's check. Let's import from Ultra Analytics YOLO. Okay, it's importing successfully. And this is the same thing I discussed in that, like you can execute using CLI, you can execute using Python SDK, that means Python script. Okay, so anything is possible. So this is the same example I showed you here. Okay, so I'm skipping this part. So you just start from their custom training. Okay, so this is the custom training part. So here basically I kept my data inside my Google Drive, so that's why I need to first of all mount my drive. Okay, I need to connect my drive to my Colab. Okay, so let's execute this cell, connect to Google Drive. Let's select my account, allow. Okay, it's done. Now if I refresh here, see it has been mounted. Now what you need to do, you just need to go to the location you have kept your this one, your data. So let me go. So I kept inside classes YOLOv8. Okay, so this is my folder. So I will copy this folder path, copy path, and here I just need to paste. Okay, now let me execute. So now guys, I'm inside this folder location. Okay, uh, so I'm inside this location. Now I think I can see everything. So if I take a new cell, if I just write ls, okay, see I had data, these are the file present. Okay, now what I need to do to start the training, uh, first of all, let's copy this path and replace here. Okay, so this is the training command, guys. Okay, so this command actually is for training. So basically here, what you need to do, we have uploaded our data, right? Here we have uploaded our data. So let me open my data set again. This is the data. So inside that we created one file called data.yaml. Okay, so just like upload this data.yaml in like in your YOLOv8 like folder. Okay, like outside of the data. Okay, because this thing we need, it will look for your data set. Okay, now once it is done, so here if I refresh here, I would be able to see. See guys, data.yaml is there. Now I'll open this data.yaml. Okay, now here you just need to change the path of your data. So I'll expand the data. So first of all, you need to give training image file path. So I'll expand the training and I will copy this image path. Okay, and I will mention here. Okay, then similar wise I will do for my validation. So I'll expand the validation, copy the image path. Okay, that's it guys. You just need to do this thing. Now save it, press Ctrl S and remove this thing. Okay, now here let me show you the training. So basically what I'm giving, I'm just running the same thing, YOLO task I want to perform detect. Okay, as I told you, it has three mode, three tasks. Okay, and mode is equal to I want to like perform training. Okay, as I already showed you, training. Okay, and model I want to use, I'm using this model. If I show you this S model, small model. Okay, so here I'm giving the model.pt data YAML. Okay, I'm providing because it is inside the same directory as I already showed you. If you do ls again, so this data YAML you would be able to see. Okay, so I'm giving data.yaml, data is equal to data.yaml. Inside data.yaml I mentioned all of my image path, right? So it will automatically take that images from that folder. automatically it will take those labels on the, from this folder. Okay, epochs you just need to mention here. So let's take uh, 25 epochs, or let's reduce to 10. Okay, uh, or let's take 25, it's fine I think. Okay, then image size just mention with respect to image size. So if I show you my image size, so if I come here, if I open an image, properties, go to details. So see, this is my image dimension. Okay, with respect to image dimension you can set. So I've taken 224 and plots is equal to 2. Okay, so this is the command you need to execute. Now let's execute. So basically it will first of all download the model. See guys, okay, this is the model architecture. Then it's scanning the data. Okay, it's looking for all the images and all the labels are presented or your directory or not. Okay, if there is something wrong, so it will throw error like this file is not found. Okay, basically before starting the training it will scan your data whether it is in correct format or not. Okay, so guys, checking has been done. Even if you see, it has also applied some of the augmentation technique during runtime and it has started the training. Here if you see, the first epoch is running and you can see the class loss box locks. Okay, everything you can see. So guys, it will take some time to train. So I will come back once it's done. So guys, as you can see, our training is done. Okay, so we have trained 25 epochs and this is the final results. So here you will get all the classes like matrices like map matrix. Okay, then everything you will get here, and this log is very good guys. Every information you will get. Okay, so apart from the log, if you want to see like see, it has created one folder here. If I show you called runs. Okay, if I refresh here, now if you open the runs, so here you will get something called detect. Okay, inside that it has created train. Okay, and it has saved all the matrices like confusion matrix. Okay, batch images. Okay, then some detection. Okay, everything, even your precision curve. Okay, precision recall curve, even loss.csv, everything, every matrix actually will get here. And inside weight, it has kept my two weights. One is base.pt and last.pt. So we have to use this base.pt. Okay, for our inferencing purpose. So detection is done successfully. Now if I just execute this one, I'm just listing all the thing inside my train okay, train folder. So see guys, these are the images actually it has. Okay, now I'll just remove two because I was running second time, and if you run this second time it will create another folder. Okay, here let me show you another folder called train 2. Okay, inside that it will save again the same metrics. Okay, so I was when I was running previously, I was doing some experiment. Okay, so I was running for second time, so that's why I had given 2 here. Okay, but here let's give here I but here I only have one called train folder, so that's why I just removed 2. Okay, now let's execute. So it will basically plot your confusion matrix. Okay, so this is the confusion matrix guys. Okay, multi-class confusion matrix. Now if you want to also see your result.png, so you can also see that this is the result.png, and see as per your epochs is increasing, your loss is also decreasing. Okay, so basically to get a good accuracy you need to train around 300 epochs or 500 epochs. Okay, you will observe very good accuracy there. Okay, so see some of the prediction batch images here. If you see, it is detecting successfully. Okay, see guys, detection is like pretty good. Okay, now it was like our training. Now if you want to validate on your like okay, on your test data, so you can also do it. So for this is the command. So basically here I'm running YOLO. Task is equal to I'm defining detect. Okay, and mode is equal to I'm doing validation because I want to perform validation, but previously I was giving train. Now here I'm just relocating my weights. Okay, so here inside my runs folder, inside detect, inside train, inside weights. Okay, I had base.pt, this model location I'm just copying and giving here, and data.yaml I'm giving. Okay, now if I execute, so it will actually validate. Okay, okay, your on your custom data. So basically it will like validate on your test data. Okay, So guys, this is the validation score. Okay, so here every matrix you will get. Now it was the validation. Now if you want to inference, okay, on your test data, so here you can do it. So this is the command. Just run YOLO task is equal to give detect predict mode is equal to predict, because I want to do prediction. Give your model file path, confidence score you can mention, okay, then just give the source image. Okay, I have my test data inside here data, inside test I have all of my test data. Okay, so that's why I'm giving this path test images. Okay, now if I execute, so it will it will take all the images, okay, and it will do the prediction. But again, one issue, see guys, these are the prediction: two globes, okay, then two globes, one gloves, jacket, gloves, okay, helmet, gloves, goggles, okay, every detection you will get. But I told you one issue, I'm not getting that folder inside runs. Actually it should create one folder called predict. Okay, inside that it should save all the images, but it's not saving. I don't know why, because I think they're still developing this thing. Okay, I think it will work for you after after some time. Okay, because they already told here. If you see, I think showed you this notebook. Okay, it is still under heavy development. So basically, after doing all the detection, it will save all the detection file inside one folder inside runs called predict. Okay, inside you will get all the images, all the detection images. Okay, so basically how it will look like. So here I kept one example. Okay, so these kinds of images actually will get, okay, as a detection. But here it is giving only this name, like how many like helmet, goggles and jacket it has detected. Okay, instead of like creating the folder. I think uh, it is the issue from their side. Okay, I think it would be fixed. Okay, after some time. So yes guys, I think now you got it, like how to use YOLOv8, okay, for this object detection purpose, okay, on your custom data. Now I think you can train your own data set. Okay, it's very easy to use. So I will share this notebook with you. You just use this notebook as it is. Okay, so everything I will share with you. So yes guys, I hope you like this video. Okay, if you have liked this video, just let me know, like just comment below like how helpful it was. Okay, and if you want these kinds of video in future, just do let me know. Okay, and just subscribe to my channel so that I can get motivated to create these kinds of video. Okay, try to share this video with your friends and family. Okay, try to give a like on this video. So yes guys, this is all about from my side and from this video. Thank you so much for watching this video, and I will see you next time.